Okay, this is 5.2 properties of functions, and functions are related to the idea of input-output machines. So if you input something and follow the rules of the input-output machine, you will get the output you desire. So if we look at this one, what is the rule for the input-output machine above? Well, it states that if I put a number in, I will multiply it by 2 and add 3 to it. So for instance, if I put 1 in, I will get 5. If I put 2 in, I will get 7. So if you didn't get that on your own, make sure to take some time and kind of rationalize that to yourself. Pause the video if you need to, go back, think about it, that this says if I put something in, so if I put 3 in, multiply it by 2, and then add 3 to it, I should get 9. Okay? Step by step. The first set of elements in a relation is called the domain. This is the independent variable. The set of related second elements of a relation is called the range. This is the dependent variable. I'm going to underline independent variable as well. A function is a special type of relation. So a function is a relation, but a relation is not always a function. This relation on the left here associates a vehicle with the number of wheels, and this relation on the right associates a vehicle with the number of wheels it has. So which of these two relations is a function? Prove this by creating a set of ordered pairs for both relations. So if I look here, my first one, I have 1, unicycle, comma, 2, bicycle. Sorry, that should be curve brackets, 2, motorcycle. At this point, I'm going to stop because I see that I have 2 of these right here, the same independent variable. This is no longer a function. So if I look at this one on the right, even just looking at the arrows, each arrow only leads once from this guy. So this is a function. If I want to identify functions, determine whether the relation is a function. So we are looking to see if each x value, each independent variable has exactly one dependent variable it associates with. So if we look at this one here, check to see if any of the ordered pairs have the same first element. So we have right triangle, acute triangle, square, rectangle, regular hexagon. So this one is a function. My second one is down here. 1 is a square of -1 and 1, but 4 is a square of 2, -2, and this one is 9, -3. So we have 2 arrows leading from multiple spots, here and here. So because of this double look, this double arrow, this is not a function. It is a relation, but is not a function. Describing functions. The table shows the masses, m grams, of different numbers of identical marbles, n. Why is this relation also a function? This relation is also a function because for each number in the first column, there's only 1 in the second column. So it's not like saying that there's a 2 here as well. That doesn't exist. So this one is a function. B, identify the independent variable and the dependent variable. Well, n, the number of marbles, is the independent, and m, the mass of the marbles, is dependent. Because the mass doesn't influence the number of marbles influences the mass. Our domain and range. The domain is just a listing of all the elements in the table, and same with the range. Oh, I am missing one right here. So it should be comma 6. Sorry about that. Yeah, and I got all the ones for the second one. Okay, this table shows the cost of student bus tickets, C, dollars for different numbers of tickets, N. Why is this relation also a function? Same reason as before. Each number in the first column, there's only one in the second column. B, identify the independent variable. The independent variable is the number of tickets, and the cost is dependent on that. The domain is 1 to 5, and the range starts at 1.75 and increases all the way up to 8.75. And the last thing you're going to learn how to do in this is you're going to learn how to use function notation to determine values. Function notation shows that the dependent variable relies on the independent variable. So a lot of what we dealt with before was like y is equal to x plus 5. For example, d is equal to 4t plus 5. Which is the dependent variable? Which is the independent variable? So this value here is dependent because it relies on what's happening in here. Thus, that means that t is the independent. To write this as a function notation, we say the d relies on t is equal to 4t plus 5. So that's saying the distance depends on time, for instance, is equal to 4 multiplied by time plus 5. The equation V is equal to negative 0.8 d plus 50 represents the volume, V liters of gas remaining in a vehicle's tank after traveling d kilometers. The tank is not refilled until it is empty. The function notation is V d is equal to negative 0.08 d plus 50. Determine the value of V600 is equal to negative 0.08. 600 plus 50. Simplify this down, gives us 2. This means that when the car has traveled 600 kilometers, there will only be 2 liters left. Determine the value of d when VD is equal to 26. So this says VD is equal to 26. So that means 26 is equal to negative 0.08 d plus 50. Solve. Minus 50 minus 50. We get negative 24 is equal to negative 0.08 d. Divide. Oops. This number means that after 300 kilometers, there's 26 liters in the tank. Okay, let's do another one. The equation C is equal to 25N plus 1,000 represents the cost C dollars for a feast following an Arctic sports competition where N is the number of people attending. In function notation, so C depends on N is equal to 25N plus 1,000. Determine the number of C 100, so when 100 tickets are sold, or sorry, 100 people attend, so 25 multiplied by 100 plus 1,000 is equal to 3,500. So it'll cost $3,500 to provide a feast for 100 people attending. So this is 5,000 is equal to 25N plus 1,000. Subtract 1,000 over. Divide by 25. N is equal to 160. So that means when it costs $5,000 to hold the feast, 160 people are attending.